So we're about ready to start jumping into some of the meat of the class. And the very first thing I want to cover is an introduction to threads. I had very briefly talked about threads when we did the introduction to concurrency portion of the course last time, but we didn't go into much detail. So now it's time to really start diving in. So we're going to talk about how Java provides mechanisms called threading or threads in order to support concurrency. And we'll see very shortly, and you'll get some practice with the assignments, that concurrent apps use Java threads to simultaneously run multiple computations that potentially interact with each other. Sometimes they interact, sometimes they don't. The simple examples that we'll look at here don't necessarily interact, but more complicated ones will. And that, of course, will motivate the need to talk about synchronizers and various synchronization mechanisms that Java provides. You'll see some icons I use a lot in my slides. I'm a very visual person, and I find myself understanding things better if I can visualize them. So you see a lot of diagrams like this, and I'll kind of talk through in a minute what they mean. So threads are the most basic way of obtaining concurrency in Java. There are other ways to obtain concurrency that we'll talk about later, like thread pools, but under the hood, they all use threads in one way or another. So it's important to understand what threads are. In their most basic form, a thread is a unit of computation that runs in the context of something called a process. And we'll talk about what a process is. We'll talk about what a thread is. It's good to know those things because they also have a habit of showing up on quizzes. So keep in mind, a thread is a unit of computation. That means it can run instructions. A process, in contrast, is a unit of resource allocation and protection. And processes are really things that come from the operating system level, like Windows or Linux or Solaris or whatever your favorite operating system may be, Mac OS. And so the process is used to allocate resources like allocate memory, allocate file descriptors, allocate sockets, and so on. And it's also the unit of protection in the sense that two processes can't directly share anything, like share memory, for example, without doing some additional stuff. And so you can't accidentally access the contents of something in another process. And that's very important because that's a way we isolate and protect one application or one service from corruption, either intentional or accidental, from another process running on the same machine. A Java thread runs on one or more processor cores during its lifetime. So over time, the threads that you allocate or that are allocated on your behalf by other parts of Java will be mapped to the underlying processor cores. And of course, the processor cores are really what do the work. The threads are essentially virtual or logical abstractions that get mapped down to physical processors, physical processor cores, one way or another. And that's what actually does the real work. So the cores are ultimately what make things run in parallel, and the threads are what allow things to run concurrently. And we'll distinguish those in a bit more in a second. One of the cool things about modern systems is you can have multiple processes that have multiple threads. By default, a process starts with one thread. That's the main thread, or sometimes called the user interface thread, depending on how you're using it. But you or the underlying Java execution environment can spawn more threads to do other things concurrently or in parallel, depending on how you set things up. And the multiple threads are then multiplexed and scheduled and managed and monitored and so on by the underlying operating system scheduler, which runs in the OS kernel, and perhaps part of the Java execution environment, like the Java virtual machine. So those are things that are kind of below the radar screen that we care about under the hood, and as it were. We're not going to talk a lot about OS kernels or the internals of the virtual machine too much. We might touch on it a little bit, but what we care about are the Java threads that are where the application code is going to run. Now, Java threads running within the same process can communicate with each other and interact with each other in several different ways. One way to do this is by sharing objects. And we talked about that before when we talked about Java synchronizers briefly in the introduction section to concurrency. And we'll talk a lot more about that because that's a key part of Java and a key part of this class are synchronizers, things like reentrant locks, things like condition objects, things like semaphores, and you'll get a chance to play around with all that kind of stuff. There's also ways of communicating by passing messages from one thread to another. And we'll talk a lot about those things as well. So you'll get a chance to learn about these different techniques. And you'll also see how you can implement mechanisms like message passing by using more fundamental shared object synchronizers. So you can implement something like an array blocking queue or a linked blocking queue using more primitive shared objects like Rantrate lock or condition object. And that'll come a little bit later in the course. If you have threads in different processes on the same machine, or to some extent on different machines, depending on the configuration you're using, there's other ways to communicate between them. So if you have two threads in different processes on the same machine, then you can use shared memory. And Java doesn't really have support for shared memory, but Android does. And so you could use Android's shared memory mechanism, which is called AshMem for Android shared memory. Or more commonly, you could use some kind of message passing that goes across processes, which is sometimes called inter-process communication. And there's a bunch of different ways to do that in Java using things like sockets. And there's also a bunch of ways to do that in Android using various techniques like the binder framework and so on. We won't talk a whole lot about that in this class, but if you take my MOOC or my MOOCs on Android app development, you can learn all about inter-process communication mechanisms that exist on Android. So we're going to focus primarily in this class on interactions and communication between threads in a single process. But be aware that those techniques generalize to communicating between processes and different threads that run in different processes. Now, this is an important topic, and this was almost guaranteed to show up on the quiz. So every Java thread leverages some unique state from the underlying operating system thread. So there's a thread that runs in the operating system, typically in the kernel, and then there's also this Java level thread. They're not unrelated, but they're not the same thing. They're different pieces of the same puzzle, or two sides of the same coin, or something like that. And so some of the things that are unique for each thread will be its runtime stack, and you can see that indicated graphically here by kind of a stack of different colored boxes, which correspond to so-called activation records. If you've taken the programming languages class here, you probably know what an activation record is, but basically what it is, it's just a stack frame that keeps track of calls that are being made. And it's needed for very important things like recursion, but it's used in all modern languages like Java and C++ and C to handle method calls and function calls. Each thread also has its own instruction counter that keeps track of where it is in the instruction stream, where we're executing at any given point in time. That, of course, is very important in order to be able to have the operating system atomically suspend and resume threads in order to be able to preempt them when their time quantum has expired. It can stop a thread at whatever state it's in, put it off to the side, let another thread run, and then later when it's that first thread's turn to run again, pick it up where it left off and let it keep executing. And there's also other various registers that are unique. There's also something else that's unique to each thread, which is basically things like its thread-specific storage resources. So runtime stack, instruction counter, thread-specific storage, those are all unique things that are unique to a thread. There's also some state that's shared by all threads within a process. And this would include things like the memory, the dynamically allocated heap that all Java classes in a process can access. When you say new stack, new array list, new hash map, or whatever you're allocating, that's coming off of a global heap that's shared by all the threads in that process. Some other things that are global would be I/O handles, like file handles to open files, or socket handles to open sockets, and other things like that. And in fact, you could also share, depending on how you do it, you could also share other types of state. But the key thing that's shared would be state that's not part of the thread and the thread's implementation. So it's important to appreciate the differences between what's part of a thread uniquely and what's shared. And of course, the minute things are shared between threads, then the whole issue of shared mutable state rears its ugly head, and we need synchronizers to protect against those types of problems. So that's the end of our overview of Java threads. At this point, you should have a fairly good conceptual understanding of threading, but you probably would be hard pressed to write a lot of Java code. So we're going to talk about that next.